Right. In BGP, we got two different types, I can say. Two different names are given to BGP based on where it is configured. If BGP neighbor is between the routers that are in same autonomous system, then they are called as IBGP. If the two neighbors are in different autonomous system, then it is EBGP. Like, local friend, foreign friend. Friend is friend. BGP is BGP. But when will you say local friend? When that friend is in your own location. When will you say foreign friend? When a friend is in different country. But the friend is friend. No doubt. Friend is not father. Friend is always friend only. He cannot become mother, he cannot become father, he cannot become wife, he cannot even become a dog. Friend is a friend. Likewise, BGP is BGP only. Whether it is IBGP or EBGP, same protocol, BGP only. It's not two different protocol. Same protocol. Based on their presence, based on their location, they get different names. If two routers are in two different autonomous systems, they are forming neighbor using BGP protocol, then that neighborship is called as EBGP. When two routers are in same autonomous system forming neighbor, they are called as IBGP. It is only one protocol, but based on where they are, names are given differently. Now you may ask a question in your mind, why the name need to be different? Why the name need to be different? Why do you call local friend and foreign friend? Local friend, you can easily meet him. But the foreign friend, you need to plan a lot. Save some money and then apply the visa and then go to the airport. Without doing those things, you can't meet your foreign friend. There are additional care to be taken. Without taking visa, when you go to airport, it is a waste of time. They are not going to allow you to travel. Or without taking passport, going to an airport to meet foreign friend is not possible. They won't allow you. But you can go and meet your local friend without passport. So what I'm trying to say here is, there are policies whenever you are trying to meet your foreign friend. Those policies are not there for local friend. Likewise, when you are forming neighbor with a router, BGP neighbor with a router, that is in same autonomous system. No much policy because it's same autonomous system. Your own router, you are trying to form neighbor with your own router. It's your own router. IBGP is forming neighbor with the router that are in same autonomous system, your own router, where there is no strict rules in forming neighbor, sharing route updates, advertisements. You don't have strict rules there because it's your own autonomous system. Whereas with EBGP neighbor, there are rules. Strict rules. Because it is forming neighbor with another autonomous system that's not yours. Based on the rules, if you try forming neighbor, the neighbor autonomous system is going to accept you. If you don't play by rule, they don't accept us. Because you are forming neighbor with another autonomous system. So you need to play by rule. That is why the name also they have given you different so that you will understand that this neighbor is not same like that neighbor. So, is EBGP, IBGP, are they two different protocols? Answer.
Same protocol.
Very good. It's only one protocol, BGP.
Yes.
Now, what is BGP peer? Peers are also called as neighbors, or neighbors are also called as peers. You can use this word interchangeably. That's okay. BGP neighbor or BGP peer, both are same. What does BGP peer or neighbor means? It means that those two BGP router can establish neighbor relationship successfully. They are only called as BGP peers or BGP neighbors. If the neighbors can be established successfully, then you can say they are BGP peers. Neighbors. A crocodile and a monkey. Crocodile and a monkey. Are they neighbor?
No.
They cannot form neighbor. One day what happened? This crocodile said, I'll take you to my home. Come, sit in my back. It took the monkey inside and it was trying to eat the monkey. So monkey is now aware that this crocodile is not a trustworthy neighbor. From that day till today, monkeys are not ready to trust crocodiles. They cannot establish neighbor relationship. They cannot become a neighbor because monkey will form neighbor only with monkey. Crocodile will have neighbor only with neighbor, another crocodile, because their mindsets are like that. Monkey mindset and crocodile mindset cannot form neighbor. Likewise, only those two routers that are properly configured with all necessary informations that are supposed to be there, like neighbor address, next hop, etc. Most importantly, update source and neighbor address. We'll talk about that in next chapter. So only when there is necessary configuration properly configured on both sides, this router will accept that router will accept this router. If one is configured as crocodile, another is configured as monkey, they don't form neighbor. Both should be configured as monkey or crocodile. That's very, very important. Only then they form neighbor. When two BGP speaker, what does that BGP speaker means? The routers that are configured with BGP neighbor statement. Hey, crocodile, I want to form neighbor with you. My name is monkey. Then crocodile will say, oh, you are a monkey. I'm a crocodile. How can we form neighbor? No, not possible. So they don't form neighbor. They are BGP speaker, but they are not properly configured. To establish neighbor relationship, both should be correctly configured. Whatever this guy should say, only then that guy will accept. This guy should say, hey, I'm a monkey family. Hi monkey, how are you? Shall we form neighbor? Then he will say, hey, I'm also monkey. Thank you. Let us form neighbor. Oh, come on, dude. Neighborship comes. You will understand what I mean when I see the configuration. Neighbor address should be correctly configured. Update source should be properly configured. That's what I mean. Now, any two routers that formed a TCP connection to exchange routing informations are called as BGP peer. This is the important story which I was telling you. You have two routers and you have configured with proper configuration. Now they are going to exchange the information based on your configuration, and those informations, when they match, they are accepted as neighbors. Now, as I said, there is an eBGP. When BGP is running between the neighbor that belong to different autonomous system, it is called eBGP. When eBGP neighbor by default, okay, this is important point. eBGP neighbors by default need to be directly connected. Right? So, when BGP is running between neighbors that belong to different autonomous system, they are eBGP neighbors. Condition is they need to be directly connected by default. Very important. You may think like, what? I don't see something different here. When we form OSPF neighbor, they are directly connected. When we formed EIGRP neighbor, they were directly connected. What is special here? Okay, that's a good thought. That's a very good thought. But you're going to see in the next slide IBGP, internal BGP. That is the difference. That one need not to be directly connected. That's why this point here it is important. If it is IBGP, the neighbor need not to be connected directly. This is only for eBGP. Let's see the next one. You see, the routers that are in same autonomous system 65500, they all form neighbor, which means they are IBGP neighbor. And you see the second line, the neighbor do not have to be directly connected. You understood?
No, sir, I couldn't get your point, sir. Could you repeat one more time, sir?
Okay. Let's say we don't have BGP on B. B router, no BGP. BGP is running on A, C and D. They can form neighbor. This is not possible in OSPF. This is not possible in EIGRP. But in IBGP, it is possible. Wait a minute. Don't jump into any conclusion. Listen to me carefully because you are not still clear with the concept. I want to repeat the example. BGP is not running on which router?
B.
B. If OSPF is not running on B, will OSPF form neighbor with between A and C?
No, sir, it's not possible.
Not possible. Because OSPF uses hello packet sending it to a multicast address. So B needs to be there. Only then B can form neighbor with C. A forms neighbor with B, B forms with C. But BGP is not like OSPF. BGP is a TCP protocol. If there is a reachability between A and C, let's assume you have a IGP protocol, example, EIGRP or OSPF. What is running inside your organization? Let's say OSPF.
OSPF,
With the
yeah.
help of OSPF, will you be able to telnet from A to C?
A to C. Yeah, I can do the telnet A to C.
What is the protocol telnet uses? TCP or UDP?
TCP, obviously.
Now, what is the protocol?
Secure connection.
What is the protocol BGP is using?
TCP, yes.
If telnet can be done between A and C,
Okay.
IBGP can also be formed between A and C because there is ping between A and C. Who is providing the ping? Reachability, OSPF. Because there is a reachability between A and C, BGP can establish neighbor without running BGP on router B.
Okay. This is a special for the B.
For eBGP also you can do, but by default not recommended, need to be directly connected. But even for eBGP you can do it, but for IBGP we always do in the production. In the production we will not be running BGP on every router. We will be running only on the border routers. A is one border router, D is another border router, C is another border router. B is not border router. So we will not be unnecessarily wasting the CPU on B. We will only form neighbor between A, C and D. And A will be forming eBGP with Z. D will be forming neighbor with Y, C will be forming eBGP with X, and inside A, C, D will form neighbor. So you can avoid unnecessary CPU B. And between A, C and D we will put one tunnel using MPLS. That's too much, it's CCI syllabus, let's not get into that. But what I am trying to say is in the production, we will not be running BGP, IBGP on every router. We'll run only on the edge routers because IBGP can form neighbor even with the router that are remotely present. You understood?
Okay. So which means B running OSPF using A and C can communicate ping, so that we can able to make sure the BGP connection can run it A and C without B.
Correct.
Okay, understood, sir. It may be a OSPF, it may be the whatever protocol, which means for the EIGRP, IS, anything. But ping should be happen. We have to make sure it, right?
Yes.
Okay, okay, sir. I got clear for this concept.
Mm-hmm. So this is special with BGP only because it is TCP based protocol.
Okay.
Okay, what we are going to see now is a very big concept, and this page alone cannot teach you the whole thing. This page, next page, and next page. 3 pages are one topic. This page and the following 2 pages need to be understood under one topic. Now let us see what is there inside in this picture. How many autonomous systems do you see here?
Oh.
Hmm?
3 autonomous systems, sir.
Only 3 autonomous systems.
Yes.
Let us say on router A, you have a network 1.1.1.1. And on F, you have network 3.3.3.3. If 3.3.3.3 need to ping 1.1.1.1, what is needed? Tell me. I want to ask you the question again. Where is 3.3.3.3?
F.
Where is 1.1.1.1?
Router A.
Okay, if F from 3333 needs to ping A 1111, what is needed on F?
Ping only there, so that echo. And protocol needs to run from outside ABGP.
Wait, what is needed on F is route to reach 1.1.1.1 is needed in the routing table, correct?
Okay. Yeah, that's right, sir.
You need a route. Now, can A give directly to F? No. Can A give the route directly to F?
No.
No. So A will give to whom?
B.
Which one will give to F? Which one will give the route 1.1.1.1 to F?
A.
E
Could
only
you
will
repeat the
give to
question,
F.
sir?
E only will give to F, correct? Not A.
Okay, and here, yeah, obviously, yes, E give to finally
E
F.
will give to F. Now, listen. A is giving to B, and B have to somehow give to E either via D or C, and E will give it to F, correct?
Correct, yes.
Okay.
Clear.
Now, you see there is no BGP on D and C. Do you see that in the board? Written there, no BGP.
Yeah. It's not running BGP,
No
yes.
BGP. But what is running on this 4 router?
OSPF.
OSPF. So now A is giving to B using eBGP, correct?
Yes.
And B is a neighbor with E. Can B and E form neighbor? Yes. B and E can form neighbor because OSPF is running. There is a reachability.
Okay, yes.
I told you, no, IBGP can be
internal.
No. IBGP can be with a remote router. B and E are not connected directly. They are remote.
Okay, sir.
Is B directly connected to E?
Yes, B not.
Can they form neighbor?
Yes, sir.
Yes. That is what IBGP, right? IBGP
Yes, correct,
can
yes.
form neighbor. because
remotely.
there is reachability provided by
DRC.
there is a reachability provided by OSPF via DRC.
Okay.
OSPF is the one which is providing you reachability between B and E. Using that reachability, B and E will form neighbor. We call that as IBGP. See, they have written that in the dotted line, IBGP. You see that?
Yes, sir.
So now, A gives the root 1.1.1.1 to B. B will give to E. Okay.
Yes.
B will directly give to E because it's a TCP packet. It will go through one of the router, DRC, no doubt, but it is delivered to E only, not to D
Yes.
and C. Why D and C will not have the root? Because they are not BGP. They cannot open the update. They will simply forward the update to E.
Yes, sir. Correct.
Okay. Now E will give the route to F.
Yes.
Now F will try to ping. From F the packet will come to. Now you're pinging from F 1.1.1.1.
Okay.
So
It
from
come to
F
E.
the packet is coming to E.
E.
E will try to send to whom? B.
B.
But when it try to send to B, it will go to D or C. Correct?
Yes, sir.
There it will check the routing table. Will there be root?
No.
It will drop. The packet will drop. Correct?
Route. Okay. Yes, sir.
That is what explained here. Because there is no root, the packet get discarded. Do you agree?
Okay. Yes, correct.
Instead of 1.1.1.1, here the example is 10.0.0.0. Fine.
Okay.
So now, what is the solution? This one solution is you redistribute BGP routes into OSPF. Correct?
Okay.
Then-
Okay. Yes, sir.
Then that 1.1.1.1 will be learned via OSPF in D and C. You agree?
Yes, sir. Agree.
Now will the ping happen? Yes, it will happen.
Yes.
But you see, redistributing BGP into IBGP is not recommended.
Okay.
Yes, it is not recommended. Why?
Okay.
Why it is not recommended? Why it is not recommended? Okay, my question is, why do we need to enable BGP? Why not OSPF? You will say OSPF don't have attributes. BGP has got attributes, correct?
Attributes. Yes, agree, sir. Correct.
Now, if you redistribute BGP into OSPF, what will happen? The value, the BGP attributes, everything will get lost.
Okay.
Okay, yes, sir. When you take BGP,
Okay, then, sir.
okay, then.
Yeah.
See,
Okay.
OSPF knows only cost. So if you
Yes.
give the BGP update to OSPF
Okay.
will only take that route and provide some default cost and ignore all the attribute that is coming in that update. Then what is the
Correct,
point
yes.
of me running BGP? No use, no. If I'll drop all the attributes while redistribution,
Okay.
then there is no use of BGP. Correct? Then we should have run only
Yes, sir.
OSPF everywhere.
So normal route it will come. Normal route waste போகும்.
Correct. That is why it is not recommended. You understand?
Okay. Okay. Got it, sir.
Redistributing BGP into OSPF is not recommended because the BGP's attribute will get ignored by OSPF.
Okay. Got it.
And now when OSPF gives the route from OSPF to BGP on router E, it will get like a normal update, and only a normal update will go to F.
Okay.
You understand? Only normal route
Yes,
will
sir.
go to F.
Correct.
So there is no need for BGP if you do that. That is why redistribution is not recommended. Then what is the solution? Run IBGP on all routers. So you run IBGP on D as well as
C.
C. So form IBGP between A and D, sorry, B and D, and B and C,
C.
and D and E, and E and C.
Yes.
Then whatever A gives to B, B will give to D. Using BGP only it will give, because they will have what? They will have what? IBGP. See, BGP, BGP, BGP everywhere. Got it?
Okay. Yes, sir. This is understood.
But now, there is one more thing you need to understand. You see, in this topology, is all 4 router running BGP? Yes. Are they running BGP?
No, sir.
What? No, sir.
Only OSPF.
Sir,
OSPF running
see
B and
properly,
E.
sir. Oh, BGP, 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 BGP. Is BGP running on all 4 router here?
Okay. Okay, sir.
Even in down
Okay, sir.
picture, you have BGP on all 4 routers in the middle autonomous system. Correct?
Yes, correct.
But what is the difference? Here, B is forming neighbor with the D and C. But B is not forming neighbor with E.
E.
Whereas here, B is forming neighbor with E also.
Okay.
You may ask why. See, this first one on the top will not provide route to F. Why? This is the rule. Listen carefully. The route learned via IBGP or never propagated to other IBGP peer. What does that mean? The route that is coming from A to B is EBGP, right?
Yes, correct.
Now B is giving to D. It is EBGP or IBGP?
IBGP.
IBGP. Now you see, route learned via IBGP or never propagated to other
Okay.
IBGP, which means
Oh.
D will not give the route to E. Got
E.
it?
Okay, got it. Yes.
That is
Also,
why,
same B, C. C also will not propagate it to E.
that is why we make neighbor between B and E also, so that same like it gives a copy to D, it will also give another copy to E directly.
E.
You understand?
Okay.
Now you see, that is why this need to be fully mesh.
Mesh
Full mesh means
IBGP.
what? Even with a router that is not connected directly, you should form neighbor. For example, here how many routers are there inside the
4 routers.
4. How many neighbors, IBGP neighbors will be there? 3 neighbors.
Okay, yes.
In each router,
DC.
how many IBGP router? In each router. C router எடுத்துக்கலாம். In C router, how many IBGP router will be there? IBGP neighbor will be there. 3.
2. 1,
Yeah,
2.
three.
D also is there. 3. Correct.
That is why it is called as full mesh.
Okay, okay, full mesh. Even B also I can see, D also see, everywhere will be the full mesh. Okay.
Whereas in
Got
the
it.
above picture, B is having only
Only
2 neighbor, C is
2.
having only 2 neighbor. So this is not going to work because of this rule. What is the rule? A route learned via IBGP
BGP.
or never propagated to either IBGP. Why is this rule? This rule is to prevent loop. This is how IBGP prevents loop. This rule is called as IBGP split horizon rule. What?
Okay, IBGP split horizon rule.
Correct. If someone is asking in an interview like this, what is the loop prevention mechanism in IBGP? Answer is this one. IBGP split horizon rule. Now,
Okay.
if someone is asking what is the loop prevention mechanism in EBGP, then it is autonomous system number. Okay.
Okay.
Autonomous system number loop is prevented using EBGP. In in EBGP, autonomous system number is the loop prevention mechanism. In IBGP, BGP split horizon rule.
BGP split horizon. Okay.
IBGP split horizon rule prevents the loop. You understood? Okay.
Yes, I got it.
Okay. So we have finished the second chapter. Now, one more chapter I'll teach you how to configure BGP. With that, I'll finish your CCNA, CCA of BGP. Remaining you will see when you come to the next level.